Okay, so at this point we had left off with filling in this table. So the other video I had you stop, fill out this table before you started this video. Okay, so we filled out how much amount we would have if our interest was compounded 4 times a year, monthly, 12 times a year, or every single day. Okay, you can see the difference in the last row here. You know, this was after 40 years. How much you would have difference depending on the different compounding. Okay, so you can see there's a difference of about $3,000 from if it was done quarterly versus daily. Okay, so in problem 4, we calculated the balance of the deposit. After 40 years, which account has the highest balance? Okay, so you can see that the one compounding daily gets us the best amount of interest. Okay, yields the highest interest. Okay, so you wonder, well, how often could we compound interest? If we can do it daily, can we do it every hour? Can we do it every minute? And this is what we call continuous compounding. After you do it daily, doing it hourly and even minute-wise doesn't give that much more of a yield. Okay, so down here, the next part where they're talking about continuous compounding, what they're just showing us on these formulas, really we just use all these formulas for n equals 1, 4, 12, and 365. They're showing plugged in n for each one of those, n and the rate. Okay, and they're showing us that each one of these, and we already looked at this in the last video, this piece right here, okay, not including the t, all of this is really just a number. Okay, because we have R filled in, we have N filled in. So all that is really just a number. So if we figure out that number for each one of these, it really then starts to look at our formula like we had before. These values right here, all of these that I boxed in, these are really just all of our B values. Okay, so if I figure that out ahead of time, I can actually see what the amount of interest I'm going to make. Okay, what's my yielding interest? Okay, so that's what they're showing us down here. Each formula can be expressed like this, how we're used to seeing it from before, where B is this whole expression right here. Okay, and that's our growth factor. We saw before that if it was compounded annually, just once a year, then our growth was just 6.5%. And then we're getting more and more as we compound it more. So if we have same thing and we're using n equals 4, okay, and we plug that into the 4 went here, and the 4 went here, just figuring out what is B, what is that growth factor, we would get 1.0666. Okay, so the growth factor is 6, that whole thing, and then that means our growth rate is that 0.0666. Or in other words, we're making 6.66%. Same thing for the other two. Okay, so if we do that same thing for we already did it. We already figured out the growth factor for one time a year was 1.065. We just did it for the other one for quarterly. Okay, if we fill in n for this b right here for n equals 12, we get 1.06697. So that means we're yielding 6.697% if it's done monthly, and then annually we're going to get 1.06715. So it really means R for that one is 6.75%. That's our gain, okay, if it's done daily. So obviously we see we do have a little bit more. It's not a huge difference, but with a lot of money it does make a big difference. Okay, so they're yielding, just notice this little R sub E. Okay, that's our yielding, that's how much interest we're yielding. Okay. So to calculate this effective yield, I think I spelled yield wrong on the previous slide, so I'm sorry. Determine the growth factor, and that's what we just did. Okay, if we fill in, if we know R, we know N, then we can figure out the growth factor right there. And then from there, we just figure out what comes after the 1. Okay, remember the actual rate is the actual increase. In other words, we subtract 1 from the growth factor and we figure out how much we're actually yielding. All right, so here's another example. Okay, I'm going to jump down to this 7a because example 3, they're walking you through it, so you can go back and look at that one. If interest is compounded hourly, which means n is 365 times 24, compute the growth rate for that. So if we end up doing that, we figured out our b. Okay, so it's going to be 1 plus, our rate is still 0.065. That number of times compounded yearly is that 8,760 raised to that same power. Okay, this is going to end up getting 1.06716, meaning we have an R of 0.06716. In other words, we're getting 6.716% yield for that one. So if you compare it back up to the, if I only got it compounded 365 times a year, you can see it's not a huge difference. So let's just go through the effective yield. So this one would be in percents, we'll do it. This means you're yielding 6.5%. This one you're yielding 6.66%, 6.697%, and 6.715%. So it definitely is more as we go up. But the biggest jump comes going from, you know, if I went from 1 time a year to 12 times a year. That's the bigger jump. So write a sentence comparing the growth factor if we compound it hourly to that daily. Okay, so if I did it daily, we have it right up here, versus hourly. I'm sorry, I wrote, this one is our daily one. This one is our hourly one. If we look at the difference, it's really only a difference of 0.00001. Okay, so it was not a big difference at all in our yielding interest.